What if I told you that on October 19th, 2017, humanity received its first confirmed message from another star system? Not radio waves, not mathematical signals, but a physical object that defied everything we thought we knew about how celestial bodies behave. An object so bizarre that NASA scientist Dr. Alan Fitzsimmons called it the most extreme orbit ever seen in our solar system. For 2 years, scientists scrambled to explain Oumuamua's impossible acceleration away from the Sun without any visible propulsion. They proposed everything from hydrogen ice to alien technology. But here's what will blow your Mindor asking. The wrong questions entirely. Because in 2019, another interstellar visitor arrived. Comet 2 I Borisov behaved exactly as expected. Normal, predictable, boring. And that's when the real revelation hit the astronomical community, like a cosmic thunderbolt. Oumuamua wasn't just strange, was unprecedented in a way. That changes everything we understand about our place in the galaxy. The implications are so profound that Dr. Avi Loeb, former chair of Harvard's astronomy department, staked his entire reputation on a theory so controversial it divided the scientific community. But new evidence emerging from the European Space Agency and observations by Dr. Robert Warwick at the University of Hawaii suggests something far more mind-bending than anyone imagined. By the end of this deep dive, you'll understand why Oumuamua might represent the most important discovery in human history, and why the arrival of 2 I Borisov as a normal comet actually makes Oumuamua exponentially more significant. But first, I need your help building this cosmic community. Hit that like button if you're ready to have your mind blown. Subscribe for more universe-touring content. And drop a comment telling me what country you're watching from and what time it is there. I love seeing our global audience come together to explore the cosmos. Let me paint you a picture of October 19th, 2017. Dr. Robert Warwick was analyzing routine survey data from the Pan-STARRS telescope in Hawaii when something caught his eye. A moving point of light that shouldn't exist. Think of it like this. Imagine you're a lighthouse keeper, and every night for decades, you see the same ships passing in predictable patterns. Then suddenly, you spot something moving in the complete opposite direction, faster than it should be possible, with no visible means of propulsion. That's essentially what Warwick discovered. The object was already past its closest approach to the Sun and racing away at 196,000 miles per hour. But here's where it gets weird, and I mean scientifically, mathematically weird. Its trajectory wasn't following Newton's laws of motion. It was accelerating away from the Sun without any visible comet-like activity. When comets approach the Sun, they develop tails as ice sublimates into gas, creating a natural rocket effect. We've observed thousands of comets, and they all follow this pattern. But Oumuamua? No tail, no visible outgassing. Yet it was accelerating as if pushed by an invisible hand. Dr. Marco Micheli from the European Space Agency led a team that spent months verifying this impossible acceleration. They checked and double-checked their math. They considered measurement errors, gravitational perturbations from planets, even the subtle pressure of sunlight. Nothing explained what they were observing. The astronomical community was baffled. Dr. Alan Fitzsimmons from Queen's University Belfast called it the most extreme case we've ever encountered. This wasn't just unusual, it was physically impossible, according to our understanding of celestial mechanics. But here's what makes Oumuamua truly extraordinary: its shape. Using light curve analysis, astronomers determined it was roughly 1,300 feet long, but only about 130 feet wide. That's a length-to-width ratio of 10 to 1 more extreme than any known asteroid or comet. Think of it like a cosmic cigar, tumbling end over end every 7.3 hours as it raced through our solar system. And then came the revelation that changed everything. In September 2019, exactly 2 years after Oumuamua's discovery, another interstellar object entered our solar system. Comet 2I Borisov, discovered by Crimean amateur astronomer Gennady Borisov, behaved exactly as expected. It had a tail. It followed predictable physics. It looked like every other comet we've ever studied. This is where your mind should start. Reeling, because 2I Borisov's normal behavior didn't make Oumuamua less mysterious. It made it exponentially more significant. If interstellar objects regularly visit our solar system, and they all behave like Borisov, then what the hell was Oumuamua? But we're just getting started. The real mind-bending discoveries are yet to come, and they'll fundamentally challenge how you think about our galaxy, our solar system, and our place in the cosmic order. Here's what will blow your mind. Oumuamua's acceleration wasn't random. It followed a precise mathematical pattern that defied everything we know about how objects move through space. When Dr. Marco Micheli's team published their findings in Nature in June 2018, they revealed something that should have been impossible. Oumuamua was accelerating away from the Sun at a rate of about 510 to 6 meters per second squared. That might sound tiny, but in the vacuum of space, over the course of months, this acceleration was significant enough to completely alter the object's trajectory. Think of it like this. Imagine you're driving a car, and suddenly it starts accelerating even though you're not pressing the gas pedal. There's no wind pushing you, and you're going uphill. That's essentially what Oumuamua was doing in space, accelerating against the Sun's gravity without any visible means of propulsion. The team considered every possible explanation. Solar radiation pressure? The calculations showed it could only account for a fraction of the observed acceleration. Outgassing from sublimating ice? No visible comet-like activity was detected across multiple wavelengths of observation. Gravitational perturbations from planets? Already accounted for and insufficient. But here's where it gets truly mind-bending. The acceleration pattern wasn't consistent with random forces. It followed what's called an R2 dependence, meaning the acceleration decreased with the square of the distance from the Sun, exactly like solar radiation pressure, but much stronger than could be explained by light alone. Dr. Daryl Seligman from the University of Chicago proposed one of the most creative explanations. Oumuamua could be made of hydrogen ice. In this theory, the object formed in the extremely cold environment of interstellar space, where hydrogen could freeze solid. As it approached our Sun, this hydrogen ice would sublimate, creating invisible outgassing that could explain the acceleration. But even this elegant explanation has problems. Hydrogen ice has never been observed in nature, and it would require specific formation conditions that we've never detected in interstellar space. It's theoretically possible, but it pushes the boundaries of what we consider plausible. Then came Dr. Avi Loeb's bombshell proposal. In a paper that sent shockwaves through the scientific community, Loeb and his colleague Dr. Shmuel Bialy suggested that Oumuamua's acceleration could be explained if it were an artificial object, specifically a light sail created by an extraterrestrial civilization. The math actually works. If Oumuamua were extremely thin, perhaps only millimeters thick, with a highly reflective surface, solar radiation pressure could indeed account for the observed acceleration. Think of it like a cosmic sailboat, using starlight as wind to propel itself through the galaxy. Loeb calculated that such an object would need to be about 100 times thinner than typical asteroids to explain the acceleration while maintaining its observed brightness. This extreme thinness would also explain Oumuamua's unusual elongated shape and its lack of visible outgassing, because there wouldn't be enough material to produce detectable gas emissions. But here's what makes this theory so controversial. It implies that Oumuamua might be a piece of alien technology, not little green men in flying saucers, but perhaps debris from an ancient civilization's space program. or even an active probe said to investigate our solar system, the scientific community's reaction was swift and polarized. Some dismissed Loeb's proposal as sensationalism. Others argued that we should consider all possibilities, including the extraordinary ones, when faced with unprecedented observations. But regardless of what Oumuamua actually is, its behavior has already revolutionized our understanding of interstellar objects. And when 2I Borisov arrived 2 years later, behaving exactly like a normal comet, it raised an even more profound question. If most interstellar visitors are ordinary, what made Oumuamua so special? The answer to that question is about to challenge everything you think you know about our cosmic neighborhood. What if I told you that the most important discovery about Oumuamua came not from studying Oumuamua itself, but from observing what happened when the next interstellar visitor arrived? On August 30th, 2019, Crimean amateur astronomer Gennady Borisov was scanning the sky with his homemade telescope when he spotted a fuzzy object that didn't belong. Within days, professional astronomers confirmed his incredible discovery: 2I Borisov, only the second confirmed interstellar object ever detected. But here's where the story takes a mind-bending turn. Unlike Oumuamua, Borisov behaved exactly as astronomers expected. It developed a beautiful comet tail as it approached the sun. Its composition matched other comets in our solar system. Its acceleration could be perfectly explained by normal outgassing. In every measurable way, Borisov was ordinary. Dr. Stefano Bagnulo from the Arma Observatory led observations that revealed Borisov's polarization properties were nearly identical to comets from our own solar system. Think of it like this: if you blindfolded an astronomer and showed them data from Borisov, they wouldn't be able to distinguish it from a regular solar system comet. This normalcy was initially disappointing to some researchers who hoped for another exotic mystery. But Dr. Alan Fitzsimmons realized that Borisov's ordinary behavior made it extraordinarily significant for understanding Oumuamua. Because if interstellar comets typically behave like Borisov, then Oumuamua's behavior becomes even more anomalous. The European Southern Observatory's very large telescope tracked Borisov throughout its journey, and every observation confirmed the same conclusion. This was a completely normal comet that happened to come from another star system. It contained water ice, carbon monoxide, and other typical comet materials. Its nucleus was a few kilometers across, consistent with comets in our solar system. But here's what will blow your mind. Borisov's normalcy actually validates our understanding of how planetary systems form. Dr. Olivier Hainaut from the European Southern Observatory explained that Borisov's composition suggests that the building blocks of planetary systems are remarkably similar throughout the galaxy. The basic chemistry of star and planet formation appears to be universal. This makes Oumuamua's strangeness exponentially more significant. If the universe regularly produces normal interstellar comets like Borisov, then encountering something as bizarre as Oumuamua becomes vanishingly unlikely through natural processes alone. Consider the statistics. Astronomers estimate that interstellar objects pass through our solar system regularly, perhaps one every few months. Most go undetected because they're too small or too far away. But if they're all like Borisov normal comets with predictable behavior, then Oumuamua represents something fundamentally different. Dr. Ave Loeb used this comparison to strengthen his argument about Oumuamua's artificial nature. In his view, the fact that subsequent interstellar visitors behave normally makes Oumuamua's anomalous properties even harder to explain through natural processes. But even if you reject the artificial hypothesis, Borisov's normalcy forces us to confront an uncomfortable question. What natural process could produce an object as strange as Oumuamua? And why haven't we seen anything like it before or since? Some astronomers have proposed that Oumuamua might represent a completely new class of interstellar object, perhaps fragments of planets torn apart by tidal forces, or exotic materials formed in the extreme environments around other stars. These theories push the boundaries of planetary science into uncharted territory. The comparison between Oumuamua and Borisov also revealed something profound about the nature of scientific discovery. Sometimes the most important insights come not from finding something strange, but from finding something perfectly normal that puts the strange discovery into stark relief. But we're about to dive even deeper into the rabbit hole, because recent observations have revealed that Oumuamua's strangeness goes far beyond its acceleration. Its very existence challenges our understanding of how objects survive the journey between stars. Here's something that will fundamentally change how you think about space. The journey between stars isn't empty. It's a cosmic gauntlet that destroys almost everything that attempts to cross it. Think of it like this. Imagine trying to send a paper airplane across the ocean during a hurricane, while volcanic eruptions are going off and meteors are raining from the sky. That's essentially what interstellar space is like for any object trying to travel between star systems. Dr. Alan Jackson from Arizona State University has spent years studying what happens to objects during interstellar travel. His research reveals a terrifying reality. Cosmic radiation, temperature fluctuations, and micrometeorite impacts should destroy most materials over the millions or billions of years it takes to travel between stars. The interstellar medium isn't empty vacuum. It's filled with high-energy particles, cosmic rays, and dust grains moving at incredible velocities. These particles constantly bombard any object traveling through space, gradually breaking down its surface and altering its composition. For ordinary rocks and ice, this process is devastating over cosmic timescales. But here's where Oumuamua's survival becomes truly mind-bending. Spectroscopic observations revealed that its surface was remarkably pristine. Dr. Alan Fitzsimmons and his team found that Oumuamua's spectrum was nearly featureless, a reddish color consistent with organic compounds, but lacking the weathering signatures expected from millions of years of cosmic radiation exposure. This presents what astronomers call the pristine surface paradox. If Oumuamua traveled through interstellar space for millions of years, its surface should be heavily weathered and altered. The fact that it appears relatively unweathered suggests either a much shorter travel time or some form of protection we don't understand. Dr. Jennifer Bergner from the University of California, Berkeley, has proposed one possible solution. Perhaps Oumuamua's unusual shape and composition allowed it to self-protect during its journey. If it were made of materials that could reform or heal from radiation damage, it might maintain a pristine appearance despite cosmic weathering. But this explanation requires exotic materials or processes that we've never observed. It pushes our understanding of physics and chemistry into speculative territory that makes many scientists uncomfortable. The temperature variations during interstellar travel add another layer of complexity. Objects in deep space experience temperatures near absolute zero, then suddenly heat up as they approach a star. These thermal cycles create enormous stress that can crack and fragment ordinary materials. Yet Oumuamua appeared to maintain its structural integrity throughout these extremes. Here's what's truly mind-blowing. Computer simulations by Dr. Sean Raymond at the University of Bordeaux suggest that less than 1% of objects ejected from planetary systems would survive the journey to another star intact. The interstellar environment is so hostile that natural selection operates on a cosmic scale, destroying the weak and preserving only the most resilient travelers. This makes Oumuamua's survival even more remarkable. Not only did it maintain its structure during an interstellar journey, but it did so while exhibiting behavior that defies our understanding of physics. It's as if the universe delivered to us the ʻOumuamua survivor of an impossible journey. And that survivor turned out to be impossible itself. Some researchers have suggested that Oumuamua might represent the remnant of a far, much larger object that was gradually eroded during its journey, leaving behind only the most durable core. But this explanation struggles to account for its extreme, elongated shape and anomalous acceleration. Dr. Loeb has argued that artificial materials might be better suited to survive interstellar travel than natural ones. Advanced alloys or composite materials could potentially maintain their integrity across cosmic distances, while also explaining Oumuamua's unusual properties. But regardless of whether Oumuamua is natural or artificial, its existence proves that some objects can survive the interstellar gauntlet. And that realization is about to lead us to an even more profound question. How many other impossible travelers are out there, waiting to challenge our understanding of the universe? The answer involves a cosmic game of hide and seek that's been going on for billions of years, with implications that will reshape your understanding of our cosmic neighborhood. What if I told you that Oumuamua might not be unique at all, but rather the first member of a vast population of objects that we've been completely blind to until now? Dr. Robert Werek's discovery of Oumuamua was actually an incredible stroke of luck. The Pan-STARRS telescope that detected it wasn't designed to find interstellar objects. It was conducting a routine asteroid survey. Oumuamua just happened to pass close enough to Earth and bright enough to be noticed. But here's what will blow your mind. Astronomers estimate that at any given time, there could be hundreds or even thousands of interstellar objects passing through our solar system. We're only detecting the tiniest fraction of them, and only the ones that happen to come close to Earth. Think of it like this. Imagine you're trying to spot airplanes at night, but you only have a narrow beam flashlight. You might catch one plane in your beam, but dozens more are flying overhead in the darkness, completely invisible to you. That's essentially our current situation with interstellar objects. Dr. David Jewett from UCLA has calculated that based on Oumuamua's discovery, similar objects probably pass through our solar system at a rate of about 1 per month. But our current detection capabilities mean we're missing the vast majority of these cosmic visitors. The detection bias is enormous. We can only see objects that are large enough, bright enough, and pass close enough to Earth to be spotted by our telescopes. Smaller objects, darker objects, or those passing through the outer solar system remain completely invisible to us. This creates what astronomers call the selection effect. We're not seeing a representative sample of interstellar objects, but only the most detectable ones. It's like trying to understand bird migration by only watching the birds that crash into your window. But here's where it gets truly mind-bending. If Oumuamua represents the detectable tip of a massive iceberg, what might the hidden population look like? Dr. Avi Loeb has suggested that if artificial objects are more reflective and thus more detectable than natural ones, we might be preferentially discovering technology rather than natural interstellar debris. The upcoming Vera Rubin Observatory, scheduled to begin operations in 2025, will revolutionize our ability to detect interstellar objects. Dr. Zalchko Ivezik from the University of Washington estimates that this facility could discover hundreds of Oumuamua-like objects within its first few years of operation. But even this massive increase in detection capability raises profound questions. If we start finding dozens of objects with Oumuamua-like properties, it would suggest that such objects are common throughout the galaxy. If we find that Oumuamua truly is unique, it becomes even more mysterious. The detection paradox goes deeper than just missing objects. Our observation time windows are incredibly limited. Oumuamua was only observable for about 2 months before it became too faint and too far away to study in detail. Most of its secrets remain locked away because we simply didn't have enough time to investigate them thoroughly. Dr. ESA's proposed Comet Interceptor mission represents humanity's attempt to solve this problem. By positioning a spacecraft at the L2 Lagrange point, we could potentially intercept the next interstellar visitor much earlier in its journey through our solar system, allowing for detailed in-situ studies. But here's what's truly staggering. If interstellar objects are as common as current estimates suggest, then the galaxy might be filled with a vast network of traveling debris, natural and perhaps artificial, creating an interstellar ecosystem we're only beginning to recognize. Some objects might be carrying organic compounds or even primitive life forms between star systems, seeding the galaxy with the building blocks of biology. Others might be technological artifacts from ancient civilizations, drifting through space long after their creators vanished. The detection paradox forces us to confront an uncomfortable reality. Our solar system isn't the isolated island we once imagined. It's a busy intersection in a cosmic highway network, with travelers constantly passing through, most of them invisible to our current technology. And this realization is about to lead us to one of the most profound questions in all of science. Are we alone, or are we simply not looking hard enough? What if everything we thought we knew about how galaxies work is wrong? Oumuamua's existence doesn't just challenge physics, it forces us to completely reimagine the history and structure of our cosmic neighborhood. Dr. Gregory Laughlin from Yale University has proposed that the discovery of interstellar objects like Oumuamua reveals something profound about galactic evolution that we've been missing. For decades, astronomers assumed that planetary systems were largely isolated, with minimal exchange of material between different star systems. But if interstellar objects are common, as current estimates suggest, then the galaxy might operate more like a vast mixing bowl than a collection of isolated islands. Material ejected from one planetary system could eventually be captured by another, creating a complex web of chemical and potentially biological exchange across interstellar distances. Think of it like this. Imagine discovering that Earth's oceans aren't separate bodies of water, but part of a vast underground network connecting all continents. That's the scale of revision Oumuamua might be forcing upon our understanding of galactic structure. The implications for astrobiology are staggering. Dr. Sarah Seeger from MIT has pointed out that if organic compounds can survive interstellar travel, as Oumuamua's pristine surface suggests, then life's building blocks might be constantly moving between star systems. This could mean that life isn't confined to individual planetary systems, but might be part of a galaxy-wide phenomenon. But here's where it gets truly mind-bending. If artificial objects can also survive interstellar travel, then the galaxy might contain a vast archaeological record of technological civilizations. Ancient probes, debris from long-dead space programs, or even active exploration. Vessels could be constantly passing through our solar system. Dr. Loeb has calculated that if technological civilizations are common in our galaxy, and if they regularly launch spacecraft or create large-scale engineering projects, then the number of artificial objects in interstellar space could exceed natural ones by orders of magnitude. This would mean that Oumuamua's artificial hypothesis isn't just possible, it might be statistically likely. The discovery of Oumuamua also forces us to reconsider the timeline of galactic evolution. If objects had been traveling between star systems for billions of years, then the chemical composition of planetary systems might be far more homogeneous than we previously thought. This could explain why 2I Borisov's composition was so similar to comets in our own solar system. But it also raises profound questions about the origin of our own solar system. How much of the material that formed Earth and the other planets actually originated around our sun, and how much might be immigrant matter from other star systems? Oumuamua suggests that this question might be answerable through detailed studies of interstellar visitors. Dr. Alan Jackson has proposed that the The population of interstellar objects might preserve a fossil record of planetary system formation throughout the galaxy. Each object carries chemical signatures of its birth system, potentially allowing us to study the composition and history of countless other star systems without ever leaving our own. This transforms astronomy from a largely observational science to something more like archaeology. Instead of just looking at distant stars through telescopes, we might be able to study physical samples of their planetary systems as they drift past our doorstep. The implications extend beyond science to philosophy and human identity. If our solar system is part of a vast network of material exchange, then Earth might not be as unique or isolated as we've always believed. We might be participants in a galactic ecosystem that operates on timescales far longer than human civilization. But here's what's truly staggering. If Oumuamua represents just the beginning of our discovery of this interstellar ecosystem, then the next few decades could bring revelations that fundamentally change humanity's understanding of its place in the universe. And that brings us to a personal question that might be more important than all the science. How does this knowledge change the way you see yourself and your planet? Here's what will blow your mind. Right now, while you're watching this video, there are probably several Oumuamua-like objects passing through our solar system, completely invisible to our current detection methods. But that's about to change in ways that will revolutionize astronomy. The Vera Rubin Observatory, currently under construction in Chile, represents humanity's most ambitious attempt to map the dynamic universe. Dr. Zeljko Ivezic from the University of Washington leads the project that will photograph the entire visible sky every 3 nights, creating a movie of cosmic motion, unlike anything we've ever had. But here's where it gets truly exciting. The Rubin Observatory's sensitivity and coverage will increase our detection rate of interstellar objects by a factor of hundreds or even thousands. Instead of finding one Oumuamua every few years, we might discover dozens or hundreds annually. Think of it like this. Imagine you've been hunting for rare butterflies with a magnifying glass, and suddenly someone gives you a helicopter with thermal imaging cameras and a team of expert spotters. That's the scale of improvement we're about to experience in interstellar object detection. Dr. Mario Jurek from the University of Washington has calculated that within the first year of Rubin Observatory operations, we'll either confirm that Oumuamua was a unique anomaly, or we'll discover that it's part of a vast population of similar objects. Either outcome will be scientifically revolutionary, but the search isn't limited to ground-based telescopes. NASA's proposed interstellar probe mission would send a spacecraft beyond the heliopause, the boundary of our solar system, to study the interstellar medium directly. This mission could potentially encounter interstellar objects in their natural habitat, far from the gravitational influence of our Sun. The European Space Agency's Comet Interceptor mission, launching in 2029, represents a different approach. By positioning a spacecraft at the L2 Lagrange point, it will be ready to rapidly deploy and intercept the next interstellar visitor, much earlier in its journey through our solar system. Dr. Robert Warwick, who discovered Oumuamua, is now leading efforts to develop automated detection algorithms that can identify interstellar objects in real time. These AI systems analyze millions of observations each night, looking for the telltale signatures of objects on hyperbolic trajectories that indicate an interstellar origin. But here's what's truly mind-bending. Some of these new detection methods might reveal that we've been seeing interstellar objects all along without recognizing them. Dr. David Jewett's team is currently reanalyzing decades of archival data, looking for objects that were previously classified as asteroids or comets but might actually be interstellar visitors. The search has also gone global in unprecedented ways. Amateur astronomers like Gennady Borisov, who discovered 2I Borisov, are now part of a worldwide network actively hunting for interstellar objects. Social media and cloud computing allow discoveries to be verified and studied within hours rather than weeks. Dr. Alan Fitzsimmons leads the international community's rapid response protocols for interstellar objects. When the next Oumuamua is discovered, teams around the world will immediately coordinate observations across multiple wavelengths, from radio to X-ray, to capture as much data as possible before the object becomes too faint to study. But the search is revealing something profound about the nature of scientific discovery. We're not just looking for objects, we're actively reshaping our understanding of what's possible in the universe. Each new detection method expands our cosmic awareness and potentially reveals phenomena we never imagined. The upcoming Nancy Grace Romang Space Telescope will add another dimension to the search, with sensitivity to infrared radiation that could reveal the thermal signatures of interstellar objects. This might allow us to detect much smaller or darker objects that would be invisible to optical telescopes. But here's what's most exciting. If current estimates are correct, and the Rubin Observatory begins finding dozens of interstellar objects, each year will quickly develop a statistical understanding of their properties. We'll learn whether Oumuamua is truly unique, or just the first example of a new class of cosmic objects. And that statistical approach might finally answer the question that's been haunting astronomy since 2017. Are we dealing with natural phenomena that push the boundaries of physics, or are we discovering evidence of technology from other civilizations? The answer to that question is about to become deeply personal, because it will fundamentally change how you understand your place in the cosmic order. Let me ask you something that might seem strange at first. How does it feel to know that you're living through humanity's first confirmed encounter with an interstellar visitor that defied all our expectations? You're not just a casual observer of this cosmic mystery. You're a participant in one of the most profound moments in human history. The generation before you lived their entire lives believing that our solar system was essentially isolated. But you're living in the first era, when we know for certain that we're part of a vast galactic ecosystem of traveling objects, some of which might carry messages from other worlds. Think about this. Every night when you look up at the stars, you're seeing a universe that's far more connected and dynamic than anyone imagined just a few years ago. Those points of light aren't distant and separate. They're connected by a network of traveling objects that might include everything from natural debris to artificial probes from civilizations we can barely comprehend. Dr. Carl Sagan once said, "We are made of star-stuff elements forged in the nuclear furnaces of ancient stars." But Oumuamua suggests something even more profound. We might be made of galaxy stuff, materials that have traveled between star systems, carrying the chemical signatures of countless worlds. This changes everything about how we understand our cosmic identity. You're not just living on a planet orbiting an ordinary star in an ordinary galaxy. You're living on a world that's constantly being visited by travelers from other star systems, participants in a grand cosmic exchange that's been going on for billions of years. But here's what makes this deeply personal. If Oumuamua represents technology from another civilization, then you're living at the moment when humanity first encountered evidence of alien intelligence. Not radio signals from distant stars, but a physical object that might have been created by minds fundamentally different from our own. Consider what this means for your children and grandchildren. They'll grow up in a universe where interstellar visitors are routine discoveries, where each new object might carry secrets from other worlds. They'll never experience the isolation that defined human consciousness for all of history until 2017. The psychological impact of this transformation is still unfolding. Dr. Douglas Vacock from the SETI Institute has studied how the discovery of interstellar objects affects human psychology and worldview. Many people report feeling simultaneously more connected to the cosmos and more aware of their cosmic insignificance. But here's the paradox. While Oumuamua makes us seem smaller in the context of a vast galactic ecosystem, it also makes us more significant. We're the first generation of humans capable of detecting and studying these cosmic messengers. We're the ones unlocking secrets that have been traveling between stars for eons. Your awareness of Oumuamua makes you part of a cosmic awakening. Every time you think about its mysterious acceleration, its impossible survival of interstellar travel, or its potential artificial nature, you're participating in humanity's expansion of consciousness beyond the boundaries of our solar system. The implications go beyond science to spirituality and philosophy. Many of the world's religions and philosophical traditions will need to grapple with the reality that our cosmic neighborhood is far more active and connected than their founders ever imagined. You're witnessing the birth of a new cosmological understanding that will influence human thought for generations. But there's also something deeply humbling about Oumuamua. Despite all our technology and scientific knowledge, we couldn't definitively explain what it was or where it came from. It reminded us that the universe still holds secrets that can challenge our most fundamental assumptions about reality. This humility might be Oumuamua's greatest gift. In an age of technological overconfidence, when many people believe science has answered all the important questions, a small interstellar object showed us that we're still beginners in understanding our cosmic environment. And that beginner's mind, that sense of wonder and uncertainty in the face of cosmic mysteries, might be exactly what humanity needs as we take our first steps toward becoming an interstellar species ourselves. Because make no mistake, Oumuamua isn't just about the past. It's about the future we're about to create. What if I told you that the most important question raised by Oumuamua isn't what it was, but how many others like it we've already missed? This question strikes at the heart of one of humanity's deepest mysteries. Are we alone in the universe, or are we simply not looking hard enough? Dr. Avi Loeb's controversial proposal that Oumuamua might be artificial technology has forced the scientific community to confront an uncomfortable possibility. If advanced civilizations exist in our galaxy, and if they've been launching spacecraft or creating large-scale engineering projects for millions of years, then interstellar space might be filled with technological artifacts. Think of it like this. Imagine you're an ant colony that has never looked up, and suddenly you notice a piece of metal falling from the sky. You might spend years trying to explain how nature could create such a perfect geometric shape, never considering that there's an entire technological civilization operating above your awareness. That might be humanity's situation with Oumuamua. Statistics are mind-boggling. Dr. Frank Drake's famous equation suggests there could be thousands of technological civilizations in our galaxy. If even a small fraction of them have space programs, the number of artificial objects in interstellar space could dwarf the population of natural debris. But here's what makes this possibility both thrilling and terrifying. If Oumuamua was artificial, it means we've been sharing our galaxy with other intelligent beings for potentially millions of years without realizing it. Every strange astronomical observation, every unexplained celestial phenomenon might need to be re-examined through the lens of possible artificial origin. Dr. Ziza Osmanov from the Free University of Tbilisi has calculated that if technological civilizations regularly launch von Neumann probe self-replicating spacecraft that spread throughout the galaxy, then such probes might actually outnumber natural objects in some regions of space. We might be swimming in a sea of alien technology. Without recognizing it, the implications for SETI, the search for extraterrestrial intelligence, are revolutionary. Instead of just listening for radio signals from distant stars, we might need to start examining the physical objects passing through our own solar system. Oumuamua suggests that evidence of alien intelligence might literally be flying past our doorstep. But the technology question cuts deeper than just alien civilizations. Dr. Loeb has pointed out that if we can seriously consider Oumuamua as artificial, then we must also consider what this means for the future of human technology. If we're already detecting possible artifacts from other civilizations, how long before technology becomes detectable to other observers? NASA's upcoming Artemis missions to the Moon and planned missions to Mars represent humanity's first serious attempts to become a multiplanetary species. Within decades, our own technological debris might be traveling through interstellar space, potentially confusing alien astronomers in the same way Oumuamua has confused us. The European Space Agency's proposed Breakthrough Starshot initiative aims to send tiny spacecraft to Proxima Centauri at a significant fraction of light speed. These probes would use light sails similar to Loeb's proposed explanation for Oumuamua's propulsion. The irony is profound. We might be planning to create the very type of object that Oumuamua might represent. But here's what's truly mind-bending. If interstellar space is filled with technological artifacts from multiple civilizations, then the galaxy might contain an archaeological record spanning millions of years of technological development. Each passing object could potentially teach us about alien engineering, materials science, or even philosophy. Dr. Seth Shostak from the SETI Institute has suggested that Oumuamua's discovery should fundamentally change how we search for extraterrestrial intelligence. Instead of just looking outward to distant stars, we should be looking inward to our own solar system for evidence of visitors. The technology question also raises profound ethical considerations. If Oumuamua was an artificial probe, did it collect data about Earth and human civilization? Are we being observed and studied by intelligences we can't comprehend? These questions transform Oumuamua from a scientific curiosity into a potential first contact scenario. But regardless of whether Oumuamua was natural or artificial, its discovery has already changed humanity's approach to cosmic exploration. We're no longer just passive observers of the universe, we're active participants in a cosmic community that might be far more crowded and complex than we ever imagined. And this realization is about to lead us to the most practical question of all. What should humanity do next? Here's a concept that will fundamentally alter how you think about space. What if Oumuamua isn't just a random visitor, but part of a vast galactic communication network that we're only beginning to detect? Dr. John Matthews from Penn State University has proposed that advanced civilizations might use the galaxy's natural dynamics to create a self-sustaining communication system. Instead of broadcasting radio signals across interstellar distances, they might encode information in physical objects that travel between star systems. Think of it like this. Imagine if instead of sending emails through the internet, we put messages in bottles and let ocean currents carry them to their destinations. But instead of oceans, we're talking about gravitational currents that naturally move objects between star systems over millions of years. The concept isn't as far-fetched as it might sound. Dr. Claudio Maccone from the International Academy of Astronautics has calculated that physical objects could carry vastly more information than electromagnetic signals. A single artifact the size of Oumuamua could potentially contain the entire cultural and scientific knowledge of a civilization. But here's where it gets truly mind-bending. If such a system exists, then Oumuamua's strange properties might not be accidental. Its unusual shape, its mysterious acceleration, even its pristine surface might all be engineered. Features designed to preserve and deliver information across interstellar distances. The mathematics of orbital mechanics suggest that certain trajectories through the galaxy create natural highways for interstellar objects. Dr. Gregory Laughlin has identified gravitational superhighways that could efficiently transport objects between star systems, creating an interstellar postal service operating on cosmic timescales. If civilizations throughout the galaxy have discovered these same gravitational pathways. They might be using them to maintain contact across vast distances. Oumuamua's trajectory was perfectly designed to provide a close flyby of our solar system, almost as if it were deliberately targeting us for observation. Dr. Douglas Vakok from METI International has suggested that humanity should consider trying to communicate with future interstellar visitors. Instead of just observing them, we might attempt to send signals or even physical interceptors to establish contact. But the galactic internet concept raises profound questions about information theory and the nature of intelligence, if advanced. Civilizations are encoding their knowledge in traveling objects. How would we recognize such information? Would it be comprehensible to human minds? Or would it require forms of intelligence we can't imagine? The implications for human development are staggering. If we could decode information carried by interstellar visitors, we might gain access to scientific and philosophical knowledge developed over millions of years by countless civilizations. It would be like suddenly gaining access to a cosmic Library of Alexandria. Dr. Paul Davies from Arizona State University has pointed out that such a system would naturally select for the most durable and important information. Only knowledge worth preserving from millions of years would be encoded in interstellar messengers, creating a vast archive of cosmic wisdom. But here's what's truly exciting. If Oumuamua was carrying information, we might still be able to decode it. Every observation we made, every measurement of its properties, could potentially contain hidden messages waiting to be deciphered by future analysis. The European Space Agency's planned Comet Interceptor mission takes on new significance. In this context, if we can intercept and study the next interstellar visitor in detail, we might discover whether these objects carry any form of encoded information. But the galactic internet concept also suggests something profound about the nature of intelligence in the universe. If multiple civilizations have independently developed similar communication strategies, it implies that intelligence follows certain universal patterns, creating convergent solutions to the problem of interstellar communication. This brings us to a question that's both scientific and deeply personal. If humanity is part of a galactic community we're only beginning to detect, what role should we play in this cosmic network? What if I told you that humanity's response to Oumuamua will determine whether our species is ready to join a galactic community, or whether we'll remain cosmic children playing in our own backyard? The discovery of Oumuamua revealed critical gaps in humanity's cosmic preparedness. We detected the object almost by accident, studied it for only 2 months before it became too faint to observe, and still can't definitively explain what it was. Our response was scientifically impressive, but ultimately inadequate for such a momentous discovery. Dr. Thomas Zurbuchen, former NASA Associate Administrator, has called Oumuamua humanity's cosmic wake-up call. It demonstrated that we need fundamentally new approaches to studying interstellar visitors, including rapid response spacecraft, improved detection networks, and international coordination protocols. But here's where it gets truly exciting. Multiple space agencies are already implementing lessons learned from Oumuamua. The ESA's Comet Interceptor mission represents humanity's first serious attempt to rendezvous with an interstellar visitor. Instead of watching helplessly as objects speed past us, we'll actively intercept and study them up close. NASA's proposed interstellar probe mission would go even further, sending a spacecraft beyond our solar system to study the interstellar medium directly. This mission could potentially encounter interstellar objects in their natural habitat, providing unprecedented insights into their properties and origins. Think of it like this. Instead of trying to study migrating birds from our backyard, we're finally preparing to follow them on their journey. That's the scale of advancement these missions represent in our cosmic capabilities. The Vera Rubin Observatory will transform our detection capabilities, potentially finding hundreds of interstellar objects within its first few years of operation. But Dr. Mario Jurek emphasizes that detection is just the first step we need to develop rapid analysis and response protocols to maximize the scientific value of each discovery. China's space program has announced plans for its own interstellar object study missions, while private companies like SpaceX are developing the rapid deployment capabilities that could be crucial for intercepting unexpected visitors. The next Oumuamua won't catch humanity completely unprepared, but the most profound change might be philosophical rather than technological. Oumuamua has forced humanity to confront the possibility that we're not alone in the universe, and that evidence of other intelligences might be passing through our cosmic neighborhood regularly. Dr. Avi Loeb's Galileo project represents a new approach to this possibility. Instead of dismissing unusual observations or forcing them into conventional explanations, the project systematically searches for evidence of extraterrestrial technology in our solar system. The project has already deployed sophisticated instruments to detect and analyze anomalous objects, from interstellar visitors to unidentified aerial phenomena. It represents a shift from passive observation to active investigation of potential technological signatures. But here's what's most important. Humanity's response to Oumuamua will set precedents for how we handle future discoveries. If the next interstellar visitor shows clear signs of artificial origin, will we be ready to respond appropriately? Will we have the scientific instruments, the international protocols, and the psychological preparation necessary for such a momentous discovery? The United Nations Office for Outer Space Affairs has begun developing guidelines for studying interstellar objects, recognizing that such discoveries have implications beyond national boundaries. Oumuamua belongs to all humanity, and our response should reflect our species' collective interests. Educational institutions worldwide are incorporating interstellar object studies into their curricula, preparing the next generation of scientists to tackle mysteries we can barely imagine. The students watching this video might be the ones who solved the riddles left by Oumuamua and its successors. But perhaps most importantly, Oumuamua has inspired a new form of cosmic consciousness. Millions of people around the world now look up at the night sky with the knowledge that we're part of a vast galactic ecosystem of traveling objects, some of which might carry messages from other worlds. This awareness is preparing humanity for discoveries that could reshape our entire understanding of our place in the universe. And those discoveries might be closer than we think. Here's something that should give you chills. Based on current detection rates and improving technology, astronomers estimate that within the next decade, we'll either confirm that Oumuamua was a unique anomaly, or we'll discover that it's part of a vast population of similar objects that will revolutionize our understanding of the galaxy. The Vera Rubin Observatory begins full operations in 2025, and Dr. Zilkoe Vizek's projections suggest it could detect anywhere from dozens to hundreds of interstellar objects annually. If even a small fraction of these objects exhibit Oumuamua-like anomalies, we'll face a crisis in astronomical theory that will reshape physics and cosmology. But here's what makes the next decade truly unprecedented. We won't just be passive observers. The ESA's Comet Interceptor mission, launching in 2029, will be positioned to intercept the next interesting interstellar visitor. For the first time in human history, we'll get up close, detailed measurements of an object from another star system. Think about what this means. Within your lifetime, possibly within the next few years, we might have definitive answers about whether interstellar objects can be artificial, whether they carry organic compounds between star systems, or whether they represent entirely new categories of cosmic phenomena we never imagined. Dr. Alan Fitzsimmons leads the international community's preparation for rapid response observations of the next Oumuamua. Networks of telescopes around the world are now coordinated to immediately focus on any interstellar visitor. capturing data across multiple wavelengths before the objects become too faint to study. NASA's Nancy Grace Roman Space Telescope, launching in the mid-2020s, will add infrared sensitivity that could reveal thermal signatures from interstellar objects, invisible to ground-based telescopes. We might discover that we've been missing an entire population of warm or actively powered objects. But here's where it gets truly mind-bending. Advances in artificial intelligence are being applied to astronomical data in ways that could reveal Oumuamua-like objects hiding in decades of archived observations. Dr. David Jewett's team is already using machine learning to reanalyze historical data, looking for interstellar visitors that were previously misclassified. The implications cascade through multiple fields of science. If interstellar objects are common, astrobiology will need to incorporate the possibility of organic compounds and potentially even microorganisms traveling between star systems. The origin of life on Earth might need to be reconsidered in the Thean context of galactic panspermia. Material science could be revolutionized if we discover that interstellar objects are made of substances that don't exist naturally in our solar system. Advanced alloys or composite materials that survive millions of years in interstellar space could inspire new technologies with applications from spacecraft construction to everyday manufacturing. Dr. Breakthrough Listen, led by Dr. Andrew Simeon, is expanding its search for extraterrestrial intelligence to include physical artifacts like interstellar objects. The project now monitors for radio signals from Oumuamua-like objects, recognizing that active technological probes might be more easily detected than distant civilizations. But the most profound revolution might be philosophical. If the next decade reveals that interstellar space is filled with traveling objects, some potentially artificial, humanity will need to completely restructure its cosmic worldview. We'll transition from seeing ourselves as isolated observers to active participants in a galactic ecosystem. The psychological preparation for this transition is already beginning. Science fiction authors, philosophers, and educators are exploring the implications of a galaxy filled with interstellar travelers. When definitive discoveries occur, humanity will be better prepared to integrate them into our collective understanding. Religious and spiritual communities are also grappling with the implications. Many theological traditions will need to expand their concepts of creation and divine purpose to encompass a universe filled with traveling messengers and possibly multiple technological civilizations. But here's what's most exciting. You're living at the fulcrum point of this transformation. The next major discovery could happen tomorrow, next month, or next year. Every time you look up at the night sky, you're looking at a cosmic environment that might be about to reveal secrets that will change everything. And that brings us to the most important question of all. When that next discovery happens, when we finally understand what Oumuamua really was and what it means for our place in the universe, how will it change you? Let me tell you something profound. You are living in the most extraordinary moment in human history. Not because of any terrestrial achievement, but because you're witnessing humanity's first confirmed encounter with visitors from other star systems that challenge everything we thought we understood about the universe. Every previous generation of humans lived and died believing that our solar system was essentially isolated, that the space between stars was empty, and that we were alone with our cosmic thoughts. But you know something they never could. We are part of a vast galactic ecosystem where objects regularly travel between star systems, carrying with them secrets that could reshape human understanding of reality itself. This knowledge makes you part of a cosmic awakening that's still unfolding. When you look up at the night sky, you're not just seeing distant stars. You're seeing the launch points and destinations of a network of travelers that might include everything from natural debris to messages from other civilizations. Dr. Carl Sagan wrote that we are the universe becoming aware of itself. But Oumuamua suggests something even more profound. We might be the universe beginning to recognize that it's not just aware, but actively communicating with itself across cosmic distances through physical messengers. We're only learning to detect. Think about how this changes your relationship with the cosmos. You're not living on a lonely planet orbiting an ordinary star. You're living on a world that's regularly visited by objects from other star systems, a participant in cosmic processes that operate on scales of space and time that dwarf human civilization. But here's what makes your position truly unique. You're living at the moment of transition. The generation before you lived in cosmic isolation. The generations after you will grow up knowing that interstellar visitors are routine. But you're experiencing the discovery itself, the moment when humanity's cosmic loneliness ended forever. Transition comes with both wonder and responsibility. The choices your generation makes about how to study interstellar objects, how to interpret their significance, and how to prepare for future encounters will determine whether humanity is ready to take its place in whatever galactic community might exist. Oumuamua has given you a preview of the most important questions your species will face in the coming decades. Are we alone? Or are we simply not looking hard enough? If we're not alone, how do we make contact? And what does it mean to be human in a universe that might be filled with intelligence? But perhaps most importantly, Oumuamua has taught you that the universe still holds secrets capable of challenging your most fundamental assumptions. In an age when many people believe that science has answered all the important questions, a small interstellar object reminded you that we're still beginners in understanding our cosmic environment. This humility might be Oumuamua's greatest gift. It's shown you that no matter how advanced human knowledge becomes, the universe can still surprise us with phenomena that force us to question everything we thought we knew. Your awareness of this cosmic mystery makes you part of humanity's expanding consciousness. Every time you contemplate Oumuamua's impossible acceleration, its mysterious composition, or its potential artificial origin, you are participating in our species' growth beyond the boundaries of terrestrial thinking. The implications extend beyond science to every aspect of human experience. Art, literature, philosophy, and spirituality are all being transformed by the recognition that we live in a universe far more connected and dynamic than previous generations could imagine. But here's the most beautiful part. This cosmic awakening isn't happening to you. It's happening through you. Your curiosity about interstellar objects, your willingness to consider possibilities that challenge conventional thinking, your participation in humanity's expansion of cosmic awareness, these aren't just personal interests, they're contributions to our species' evolution. When the next Oumuamua is discovered, when we finally get definitive answers about what these objects are and where they come from, you'll be ready. You'll have the conceptual framework and the cosmic perspective necessary to integrate whatever revelations emerged out. And if those revelations confirm that we're not alone in the universe, that intelligence is common throughout the galaxy, that we're part of a cosmic community we're only beginning to recognize, and your generation will be the one that guides humanity's first steps into that larger universe. The age of cosmic isolation is over. The age of galactic citizenship has begun. And you're not just witnessing this transition, you're helping to create a dot as we reach the end of this cosmic journey together. I want you to remember something profound. Oumuamua's greatest gift wasn't the answers it provided, but the questions it forced us to ask. This small interstellar visitor, tumbling through space for millions of years before briefly illuminating our corner of the galaxy, reminded us that the universe is far stranger, more connected, and potentially more alive than we ever dared imagine. Whether Oumuamua was a natural wonder or an artificial messenger, its message is clear. We are not alone in the cosmos, and we never were. We're part of a vast galactic ecosystem of travelers, wanderers, and perhaps even intentional messengers moving between the stars. Your awareness of this reality makes you part of humanity's cosmic coming-of-age. You're living at the moment when our species transitioned from cosmic children, alone in our solar system, to cosmic adolescence, beginning to recognize that we're part of something much larger. The next time you look up at the night sky, remember that you're looking at a universe in motion, filled with objects carrying secrets from other worlds. And remember that somewhere out there, right now, the next cosmic messenger might already be on its way to change everything we think we know about our place in the universe. Thank you for joining me on this incredible journey through space, time, and the frontiers of human knowledge. If this exploration has expanded your cosmic consciousness, please like this video, subscribe for more mind-bending content, and share your thoughts about interstellar visitors in the comments below. Until our next cosmic adventure, keep looking up, because the universe has many more secrets to reveal, and the next great discovery might be just around the corner. The cosmos is calling. Are you ready to answer?